So here's a quick overview of how to do literature searching in astronomy. Why do you need to do this? Literature searching is really a critical part of doing science. It's how you start. Once you come up with an idea, you need to know who came before you and what they did, but it's also how you come up with an idea because you need to know who came before you and what they did to come up with an idea in the first place. So, in the context specifically of NITARP, you might be working on a cluster. We're not discovering the cluster. Others have probably looked at it, but in other wavelengths, or other people have used similar approaches to finding young stars in other clusters. So, we should learn from their approaches and their mistakes. In any case, if you're going to present your work in a public forum like the AAS, chances are really, really good that you're going to run into people who have studied your object before, and they're going to be justifiably annoyed if you don't know about their work. So it's really important to start the process by doing literature searching. There are three main astronomical literature databases, and they're indexed in different ways with different strengths and weaknesses, and it pays to search at least two of them. The three are ADS, Simbad, and NED. ADS is the Astronomical Data System. It's managed by Harvard SAO, Smithsonian Astrophysical Observatory. This one talks to the journal websites directly. It talks to AstroPH, which is the preprint archive, sometimes called Archive, ARXIV. It talks to conference proceedings publishers, and they have scanned in versions of old articles back through the 1800s. Their primary search is the text of the articles themselves. There's also Simbad, which is technically an acronym that stands for a set of identifications, measurements, and bibliography for astronomical data. This one's managed by CDS in France. CDS is an acronym that resolves to a French name that I dare not try to pronounce. Their primary search is the objects themselves. You can search by position or the object name, and you get all the papers mentioning anything in that region or the thing itself. And it is all interlinked to ADS. And then NED is the NASA Extragalactic Database. It's managed by IPAC. Its primary search is extragalactic objects, and that provides links to both papers and data. If you are doing extragalactic science, you definitely want to lean on NED results, but I don't do extragalactic astronomy. So most of what I do is ADS and Simbad related. And so that's what I'm going to focus on the rest of this talk here. So ADS is a direct link to the journal articles. And one of the reasons that ADS works so well is that astronomers have believed in open access literature really forever. Most astronomy journal articles and even conference proceedings get posted first to archive, which is also referred to as AstroPH. And those tend to appear in that public forum well before they appear in the journal. Anything can get posted to archive, so your mileage may vary. It doesn't have to be refereed. It doesn't have to even be submitted to a journal. Usually, professional astronomers will post to archive when it's accepted, but sometimes, depending on the subfield of astronomy, they'll publish it to archive when it's submitted, not when it's accepted. There are lots of other fields on archive too. Astrophysics is just one of many fields that publish in archive. So your mileage may vary with whatever you find on archive. The content should be the same between archive and the journal article, but there's editing and typesetting that occurs. And of course, if it's if it's before the refereed process, there's going to be changes that the referee asks for. So there may be changes in the content if it's posted to archive before it's been refereed and accepted. The typeset article is typically behind a paywall for anywhere from 1 to a few years, but the archive version is free to all as soon as it goes. Usually people submit it to archive, and then there's like a 24-hour latency before it goes public. Starting in 2022, the AAS journals are now all 100% open access. So there's no paywall for AAS journals. ADS is indexing the text, and it's trying to be smart about it, but it still ultimately comes back to what appears in the text. So for example, it's trying to be smart about how it's dealing with astronomical abbreviations. So there's a cluster called CEPH-C, but it is understanding that CEPH-C is the same as CEP-C or CEPH space C and CEP space C. But it is also looking for the term Cepheid because that could also be related. So ADS is trying to be clever, but that cleverness can sometimes backfire. It is trying to index more planetary and geology journals than it has in the past, but sometimes that can give you really garbage results. So one way to try to limit this is you have to make sure that the astronomy collections is ticked. On the left-hand side of your search results, you can tick astronomy under collections to make sure that it's only giving you astronomy journals. But because it's trying to be smart about indexing and it's incorporating more journals, it can really give you some garbage results. So M8 is the Lagoon Nebula. It's a famous star forming region. If you get in there right now and search on M8, it understands that M8 is the Lagoon Nebula. So it also searches on the word lagoon. But that is going to get you a ton of information on water worlds and marshes here on Earth. And in fact, those search results dwarf any search results you want on star formation in the Lagoon Nebula. So that's super frustrating. So you have to be kind of smart about how you use it. ADS is going to give you a wide variety of results. And here's the list of what it will give you, in my opinion, from most useful to least useful. Refereed journal articles are, of course, the gold standard. Journal articles posted to AstroPH may or may not be refereed. Then data sets delivered to various archives. That's also super useful, but you're going to need to use the paper that goes with them in order to understand how to use those data and what they mean. You can get the full articles from conference proceedings, which are typically not refereed. Sometimes they are, but typically not. ADS also includes abstracts from conferences without conference proceedings. So not only are those not refereed, you also don't get the whole paper, you just get the abstract. So not necessarily useful. You sometimes can figure out, oh, so that person's working on this. So that means you might be able to expect a journal article from that person in the relatively near future. And then the least useful is abstracts from proposals. And in that case, at least you know the data exist or will exist. And at least you know that person is ostensibly working on those data. But that's, I think, the least useful thing that ADS can give you. Simbad, totally different service. Simbad is linked to position on the sky. One of the reasons this kind of a search is necessary is that nomenclature in astronomy is a freaking nightmare. Every new catalog that comes out introduces more names, sometimes for exactly the same object. So some objects have more than 20 names, some objects have more than 50 names. ADS is going to go by text. So if you call something by a particular name, but others use a different name, if you search on that name, you may not find papers using a different name, even though ADS is trying to compensate for this. When you search by position, it doesn't matter so much because you're going to search by position, which then it doesn't matter what you call it anymore if you're searching by position. Astronomers can have tunnel vision. So for example, in Perseus, I care about the young stars. And so I'm going to care mostly about the things that are studying young stars in the Perseus molecular cloud. But Perseus is a big constellation, and there's a famous galaxy cluster there too. And I might, quote unquote, accidentally have data on the Perseus galaxy cluster. And I might look in Simbad to find cross IDs for objects in the region. And then I can follow the trail of breadcrumbs that Simbad gets me to find other papers on the galaxies in this region. Again, Simbad is position driven. So you can search by name or position to find everything in a region. And then I can work through the list of objects to find the original papers. But here's where it might get messy. If the paper is on a given star, and then maybe the paper is focusing entirely on star X, but then deep in the discussion section is comparing it to star Y, the paper will appear in Simbad as tied equally to both star X and star Y. So that gets messy when you have more than 2 stars involved. So you cannot use Simbad to the exclusion of everything else. You have to use Simbad as just the tip of the iceberg. You absolutely have to go back to the original papers to untangle what's going on. Simbad tabulates some data, but it is notoriously unreliable at doing so. You need to take with a huge grain of salt any V magnitudes, types, or classifications of objects that you find that calls them Simbad basic data, but you got to be really careful with how you use them. You need to go chase the original articles and the data tables that they're listing there in order to believe the V magnitudes or spectral types or classifications. You can, however, use Simbad to find out what other named objects are near to a region that you care about, and you might be able to then find other useful papers near your targeted objects that then you can, find more information that's relevant for the object you're studying. So which journals matter? The US journals Everything that's green here are the most important journals. So the US journals that matter are APJ, Astrophysical Journal, APJ Letters, Astrophysical Journal Letters, APJ Supplement, Astrophysical Journal Supplement, AJ, Astronomical Journal, Planetary Science Journal, PSJ, RNAAS, Research Notes of the American Astronomical Society. All of those are AAS journals. PASP is Publications of the Astronomical Society of the Pacific. ARAA is Annual Reviews of Astronomy and Astrophysics. Science and Icarus. Science tends to be not just astronomy, but everything. And Icarus is just planetary science. All of those green US journals are owned by the American Astronomical Society, so they're definitely not for-profit journals. Then all of those are open access starting this year in 2022. The UK journals, MINRAS, Monthly Notices of the Royal Astronomical Society. Then I don't even know how you pronounce that. It's abbreviated AN. It's relatively new. Nature is all kinds of science, and they had so many astronomy journals coming, or astronomy articles submissions in recent years. They started a sub journal called Nature Astronomy a couple of years ago. In the rest of Europe, you've got ANA, which is Astronomy and Astrophysics, and ANA Supplement Series, which is ANASS. I have not actually seen an ANA Supplement Series article in quite some time, so I don't know if it's still functioning or if they've just now bundled it all into ANA. There's New Astronomy Reviews, which is relatively new, and Acta Astronomica. The rest of the world, there's other smaller journals, but the ones that I regularly see are PASJ, which is Publications of the Astronomical Society of Japan, and PASA, Publications of the Astronomical Society of Australia. ADS does have articles from other places that has a lot of observatory publications. And it turns out that the former Soviet Union had lots of small observatories doing good science in their small telescopes, and ADS gives you access to lots of really good data coming from those small observatories in the 80s. But so to the first order, if you found it in ADS, is probably legit. But you always need to be cautious with unrefereed material, whether it's conference proceedings, proposal abstracts, or even many page documents that are appearing only on the archive. You have to be really, really careful about that stuff. You should only take refereed publications as believable. There's plenty of predatory journals out there. You should approach other journals and truly other article services with caution. I'm just amazed at the number of people that claiming to serve journal articles these days. It's kind of amazing, not only how many there are and what they're picking up as legit article services. It's kind of appalling to me. But you should pay attention mostly to these journals here. And basically, if it appears in ADS, it's probably okay. And if it's refereed, it's probably okay. And if it's coming from those green journals, then it's definitely okay. Other services of note, Simbad has a suite of interrelated tools that may be helpful. Via Simbad, really CDS is the parent organization for Simbad. You can download machine readable tables from many, many, many journal articles. And it's often, especially for the older journal articles, that don't have necessarily machine readable tables with the journal articles themselves. It's so much easier if you can just download those ASCII tables rather than transcribing it yourself. And then there's a service called Vizier, and that has more than 20,000 tables, both big and small, from the literature. And then you can search either by string or by position, and it'll give you back everything it finds. The results can be uneven. It can be redundant. So you have to use it with caution. There's also an SED service with InVizier, which again, just searches by position and grabs blindly all the photometry it can find. It'll make you a quick and dirty SED. It's just blindly grabbing by position and redundantly as a result, grabbing data. Like you can find WISE data in several different places. And so it'll give you 5 or 6 different versions of the same data, but it's good for a quick look to see quickly, what's out there. So I'm going to give you a demo of some of the tools, but when I'm done, here are some skills testing activities to try with ADS. I'll let you pause the video and go through that on your own, and some things to try with Simbad. Okay, so let's start with ADS because that's probably easier. So when you just load ADS, that's the website. There's all sorts of documentation and stuff, and you can make an account and stuff like that. But when you first just load ADS, that's the website. This is where you get dropped into, and it gives you examples here. It'll also try to autocomplete. So if you are interested in, let's pick something. I don't want to do something messy like Lagoon. let's do NGC 1333. Okay, so what I did was I clicked on abstract. Let me do that slower. I clicked on abstract because I want to search not the full text. I want to search the abstract for all instances of NGC 1333. So NGC 1333 is a star forming region. So when I clicked on abstract, it pre-filled part of the search box with the information, with the syntax that I wanted, and dropped the cursor in between the two quotes so that I could just start typing NGC 1333. I don't need to capitalize it. It's good with that, with the basics here. So search. Now it found 570 abstracts. Notice that it's come because it's me, because I do this all the time. It has by default imposed a collection astronomy. Now, some of the results are cross-referenced. Look, 325 refereed, 245 non-refereed. So if I'm really interested in getting the highest quality papers, I might impose a filter that limits it to the refereed. Okay, now that constraint appears up here, 325, and it's now sorted by decreasing date. So the most recent stuff is near the top. I can put in additional constraints by authors, and I can put in constraints by publications, right? If I just want to see stuff from AppJ, for example. It's also showing, here's the histogram of the years that the search has produced, okay? Some of these are the bibliography codes. So this one is an AppJ paper from 2021, 923L. That means it's an AppJ letter, and it's page 9. And the D there is not actually part of the reference itself. It's the first initial of the author. And it came out in December 2021. And over here, this is additional choices. Like in this case, I'm not physically sitting at Caltech, but because of the way I've logged in, I can access this through Caltech. But because it's AAS journals, I can get the publisher version because it's open access. So I can get the HTML version or the PDF version. I can get the version through archive PDF or the archive page directly. So if I do that, here's the archive interface. And over here, I can get PDF. But if I can't, I can do this too, because it's all open access. I can go get the PDF from the journal, and it'll take a couple seconds. There's that article, right? So let's see. I can go get the references that appear in that paper. If that's a link to, if that is a clickable link, I can get the data from that paper. The links here mean that MNRAS hasn't assigned it a permanent bib code yet. So the article is out because it came out in November, but the journal hasn't assigned it a permanent code. So that's why it's got a temporary code there. So you can go through, there's another video that I have that's on how to read journal articles. So I'm not going to go through and try to read them, but you can at least not right now, but you can at least look at the titles. There's a button up here that you can say, tell me highlights of the journals or show me the whole abstract from these articles. So it makes it easy to go through the list, and you can impose additional constraints. Like I said, you can say, look, I would just like the ones that involve corn sandal. Limit it to that, and then it's just those papers, right? And then if I want to remove that filter, I can just click on the X. So that's the kind of thing that you can do. You can also put in, let's see, let's leave those filters. Let's put in, let's see, what author can I use? Let's do author Lyman Spitzer, a person for whom Spitzer the telescope was named. So if I do that, okay, there's 134 papers that Lyman Spitzer was a co-author on. I want to see just the papers he was a first author on. I start it with the caret and search. There's 100 journal articles that he was the first author on. So that's the basic idea. You can create, if you've logged in, you can create your own personal library that it'll save the papers in your own personal library. You can search the whole text of the article. You can search by year. There's many additional fields you can use to search. It's fairly powerful. All right, Simbad. Simbad lives here. You can search by identifier. The two most common things are searching by name or searching by coordinates. So let's search by name because it's probably the most common. So let's search on M31. Okay, and you can search with a radius of 2 arc minutes. You can also search a list of objects. Submit. Okay, so it comes back with, look, it's a galaxy. So these are the object types that it has, the coordinates that it has for it, some basic data information, including some fluxes. Now it's listed a bib code for where it thinks it got those fluxes. It's got a quick view thing here on the sky. Now here, so it's got a Venn diagram where it's trying to show you M31 is a big galaxy in our sky, and so there's lots of sub objects. So it's trying to display that, all of the nomenclature mess that's there. But look, there are 39 different names for M31. There are 11,589 references between 1850 and this morning. There's additional information here. Let's go back up to the references. Let's display. It's going to take a couple seconds because there's 11,589. Well, that's thinking. Let me get another Simbad going. Let's do another one. That one's still thinking. Let's do this one. This is easier. This is, one of my favorite ones is HD 555. That's a planet host star. Instead of arc minutes, let's do arc seconds. 2 arc seconds. Submit ID. It's still chewing. Oh my goodness. Oh no, it's starting to come back. So there are all the references that it has. So look, that is a link to Simbad's copy of ADS for the paper for this. And it has 17 objects that's listed in here. Given the title, supergiant progenitors of binary black hole mergers from common envelope evolution. Clearly, it's not just about M31. M31 is maybe something that's mentioned in the context of this. There's 17 different objects. This one, ALMA resolves giant molecular clouds in a tidal dwarf galaxy. There's 17 objects in this paper. Estimating ages and melicities of M31 star clusters from LA Lamos DR6. Okay, so there's 2. So it looks like there's 2 star clusters from around M31 discussed in this paper. So you can see here, they're still actively ingesting this one because this paper is maybe late in 2021. So it's giving you some summary of it. Let's go over here. HD 555, again, basic information, view on the sky. This one only has 9 other names for itself and only 2 references. So this should load quickly. Okay, catalog of stellar diameters and fluxes. I find it hard to believe there's only 2 references. That's very strange. Right, so if I click on that, then it will launch. Come on. Sometimes it takes a little while because it's talking to, yeah. So here's the basic information, but now I can go view the reference in ADS. And you see, now I'm back in ADS's lab, right? And here's the basic information. And here, this is a link to Vizier. So then I can go and talk to Vizier about getting access to that catalog. So here's the data table. Here's a way of searching that data table that appears in that catalog. So if I just want the text, the standardized, the machine readable catalog from that paper, I can go to the FTP thing, and here it is. There's the plain text file that goes with it. But I can also search it this way. I can give it a list of targets, or I can search by position. And I can, let's see, this was the HD 555. So let's do HD 555 and then submit. And so there's the match to this object from that table. Now, in order to see what that means, I'm going to have to go read the paper and figure out what that what that means. Probably it's some kind of, uniform disk correlated flux and L for 30 meter baseline. I have to go read the paper, figure out what that really means. But you see the idea? It allows you access to that information because look, there's 465,000 Simbad objects in this paper. So so there you get the idea, right? There's lots of interwoven information, right? Lots of interwoven data that you can access in different ways because Simbad is searching by position and ADS is searching by paper. So that's the idea.